Here we are on day 42 of the beginner boost. I'm going to try to keep it down to 128 days. I thought that would be a great number. You know, as much beginner content as you can get in 128 days for like about an hour a day. And yeah, we've had a lot of people noticing a lot of things throughout the boost, sort of awakening their superpowers, which has been the idea all along. And in the process, a lot of it has involved this sort of hacker thing. And I have a feeling that most of the stuff that I do, yes, it caters to sort of any kind of terminal-based Linuxy stuff, but it does include a lot of stuff that hackers like to do. So, and today is going to be a big one. We talked about this yesterday. We talked about how networking is fundamentally related to cybersecurity and at every level, because you know it's the access path to get into stuff, to attack it or to do whatever you want to do with it. And excuse me, I got something in my eye. So today we're going to talk about clients and servers, but more than that, we're going to have fun. We're going to play around with them a little bit and make our own servers really quickly and connect to them and just understand what that means and kind of hopefully make it more relevant from just a bunch of talking that happened yesterday about how everything works. I'm just waiting a little bit here to see if we got some people in here, but even if we don't, I'm going to go ahead and start. Just to check to make sure my connections are working properly as usual. I apologize. That's what you get when you just do a stream. You don't get a nice polished experience, unfortunately. If you're here, just make some noise. Otherwise, I'll just trust that we have some people here. Yeah, I guess we do. It says the bit rate's fine. It says we're saving, so we're going to just go ahead and go. So there are a number of things I'm going to tell you right now. I was actually doing a little bit of research before the stream started that have already changed since like last year. So anything in the technology space is a moving target, which is why you just have to get used to doing that. It's also why I got to be really leery of any content that is older than a year anywhere, right? So make sure that you do the research to look into things and make sure you update them and stuff. So the first thing we're going to do today is we're just going to jump right in and use our web browser for a little bit, our actual graphic web browser, preferably Chrome if you have it. And let me see if I can. Do I have Chrome on here still? Yeah. I've been using Firefox just because it's the default, but I really don't have a preference these days. They're all bad, and I don't want to get into it. So let's do this. Go here, go into your web browser and right click on it and go to inspect element or whatever. And I mean, you can go to any web page, doesn't matter. And we're going to click on network here, right? So the purpose of what we're doing right now is to just get a sense of how, what happens when you click on a web page. We talked about how the internet works yesterday, but we didn't talk at all about what a client and a server is. Okay, we talked about ordering a package from Amazon and how it gets to you and everything, right? Well, that entire analogy applies to ordering up a web page. So you could say, if you go to rtmx.gg, actually let's go to the GitHub one, github.com/rtmxrob. That's my main site, right? And you can get my GitHub repo here. And this page all came in, and as you could probably tell, all this stuff over here did some really great stuff. This has come a long way. I mean, I've been around since before the internet came out. And so seeing how powerful these debugging tools and being able to, observability, they call it, where you can actually see how things are happening, is pretty remarkable. And I've been listening. Eventually you might understand why Chrome's just got the best tools, hands down. There's just no debate. Yeah, Firefox came out with some new stuff, but they can't even touch it. Firefox has actually got some pretty significant bugs in how it renders white space too, and it's probably time to just let it die. It's sad to say, I know, but anyway. So there's lots of versions of Chrome, by the way, that are not Googled. You can un-Google Chrome and all that stuff if you want to get into all those questions. We're not going to talk about browsers right now. We did that on like week 1. but this here, this little network trace is what I really wanted you to come in here and see. You can see all the resources that go into making up a web page. So this is not a web day. I just wanted to show you this because it shows you very, viscerally how when you request something, it's actually made up of a bunch of pieces, and every one of those pieces has to be requested. So, client server, it is kind of like, you go to the restaurant and you're like, server, I'd like a bloomin' onion, and now I would like, a tequila, and now I would like, and so you have to keep asking for all the stuff that you're going to consume that day. And you bring it out to you, and eventually they bring the bill and everything. It's that analogy holds, right? Because we had to go in here and request all of these things, and each one had to come down, and each one had a different size. It had a different amount of time to come down, and you can actually replay what came down at what specific time and how it got all put together, etc. Okay, but what I want you to look in here too is if I can see if I can find it. Where are the headers? I don't look at them every day. So what we're talking about now is the way a request is made from the server to the client. So let me just recap. So you have a server that's sitting around running all the time waiting for requests, and then you have a client that makes a connection and says, hey, give me this thing, and it's like, okay, fine, and it gives it to him in different ways. And if you played games, I mean, this is a lot of you are Twitch people, so you know about gaming servers, can't get a connection, blah blah blah, and a lot of that stuff is going on all the time behind the scenes. And the way that request happens is using another protocol. Now, we've been talking about protocols. Every time we talk about protocols, I always bring in C3PO as kind of a mnemonic device. C3PO was a protocol droid, right? He translated multiple languages, but more importantly, he knew how to be the intermediary in order to communicate between two things, not just because of the languages, but protocol, like how you have to bow a certain way when you see the Queen of England or something. So those are all protocols. Well, and they're agreements about how you're going to interact. And a protocol, so we have protocols at the lower level. And if you're going to get into networking, by the way, you have to understand this. I don't, you know what? I should probably put it on my list. Let's put it in the I'm going to put it in the list so you guys don't forget. So you need to know was it 7 these days? Have they added another layer? 7 layers of networking. And so the fun part today is the client and server, but you kind of have to know where the client and server fits in the mix. So let's actually go look really quick at the 7 layers. There's so many diagrams of this. Some people would say there's only 4. Some people say there's 6. It's hard. It depends. This is why I like being in casual. 7 layers of hell. That was my autocomplete. Did you see that? 7 layers of the OSI model, right? So the official OSI model. Okay, this has been around for so long. It's like the first thing you learn when you learn networking, right? So, but we're talking about client server. We're showing you some web stuff. Well, the web stuff is at the top layer. I think, is this layer 1 or 7? I don't remember. Is it upside down? Yeah. So let's see here. I think it's layer 7, right? It's layer 1 is the physical. Yeah, there we go. Okay. I mean, look at all these people that make all these cool things. I mean, there's so many better YouTubers out there that have got better material on this. Go watch them and learn about the OSI model, but you need to know about it, right? You'll be asked about it at some point. Like, please describe the layers of the 7 layers of the OSI model. And you're like, okay, I'll go look at them. Now, as a developer and as a beginner, you're probably just going to care about the application layer for everything, because that's usually the thing that's not working. And syntax layer, what is that? I don't know about that one. Let's go watch other YouTubers. No, seriously, there's like a lot of other really great people that are going to talk about this way more than I am. I'm just here to tell you that you need to know about it, okay? Because I want to get on to other fun stuff, but you do need to know about it. Oh, look at this picture. There's a nice, pretty picture. Smell ya later. So wait, why did it not do anything? I don't know how to internet. I don't. Okay, so I'm trying to zoom in on this so you can see it better. and I'm failing miserably. I think if I open a picture, oh wait, now, oh, let's give them credit. So this came from Electrical Funda blog, whatever the heck that is. I like their little thing though. I'm gonna zoom it. I'm gonna zoom it. We're gonna stick with this one. I swear we're not gonna stick on the 7 layers of the mall for very long. It's so freaking boring. But you have to know it. Okay, it's more fun playing with it. So the physical layer, obviously. So you know that wire that you connect to your computer to connect you to the internet. That's the physical layer. The end. Why are you doing this to me? I do not like you. Click on allow button and push subscribe to push notifications. I don't want that. All right, you're gone. You're out of here. If you're going to torture me like that, I'm just going to look at you through here. Okay. Next, above my head is the data link layer. So that's Ethernet. Did I get that right? So Ethernet is like the protocol. That's the electronic protocol. So the physical layer is, how do I make a twisted pair cable? You ever made one? We used to make them in our network. We used this network summer camp. I have a picture somewhere. And we would make our own twisted pair TCP IP cables. Super fun. You can you have to, it's actually some really interesting things with that allow it to happen. So you have to have the wires have to be twisted in a certain way so they counter each other, so they don't get a bunch of, CEO would be freaking out on this. And then those wires get twisted, and then that allows the signal to travel longer and stuff. So that's the physical layer, whether it be Wi-Fi or a connection. Now I stream, so I have a hard line right into my thing. It's also the most secure. So that's the physical layer. Data link layer. This just describes how the ones and zeros are interpreted coming over that thing, and whether it be fiber or whatever. It's a whole bunch of blinky lights that are happening at light speed. And what that gets translated into, it goes from being binary into, a stream of binary. And then, so that would, this one would be Ethernet. And so we're going to give all the layers here. So, so the only layer, by the way, does anybody know the IBM data link layer, or actually physical layer and data link layer that failed miserably? Thank God. Nobody's going to know it. It's just too old. It's like for bonus points. I'm going to put it all here. Physical layer. The only one you need to know is Ethernet. Thank God Ethernet won. There was another network that came out. No. The Cat5 is a physical layer. But token ring. I mean, I'm just having fun here. Are we going to get to the servers? Here's a relatively obscure trivia that you can be really grateful that never actually happened. Thank you, Wikipedia. Token ring was such a fail. Whoever thought it was a good idea to make a network where if any circuit in the link network, the whole network went down? I mean, how stupid do you have to be to put that much kind of money into that idea? Such a stupid idea. And it almost became the standard. It's coming from IBM, of course. And, and this is, anyway, I'm oversimplifying it. There were other types of networking that were not serialized, and thank God, right? Because somebody said, hey, we got to get blown up here. If we're going to get blown up, it's still going to work. And so then that's where Ethernet came in. And Ethernet is the thing that then, the other layers, the other stuff was able to be built upon. So you only have to know, if anybody says physical layer, actually physical layer is like twisted pair, Cat5, that kind of thing. Cat5, 6. I think they have a new one out too now. Fiber, right? And then we have what? The link layer, data link layer, which is what? That's we'll just put Ethernet. Ethernet's really the only one that matters. There are others, but this, I'm gonna get totally railed on for saying this wrong, but I don't care. Network layer, and we talked all about the network layer yesterday, so I probably should have done this first, but whatever. It's one of those old tap into my old coax rings. Oh my God. Yeah. Don't remind me. I had to administer a lab during that time. Yeah. So network layer, I'm dating myself, but I don't care. Network layer. So the network layer routes data to the different WANs and LANs. The lower layer, I believe this is IP if I have it right. Yeah. The transport layer is routes data from different WANs and LANs, ensures the delivery of the entire messenger file. So I'm pretty sure that the I don't know. I'm not. This is why we need Bob too, right? So the transport layer, I think, that's like TCP/IP or UDP, right? So TCP, UDP, and these actually, this is like a packet within a packet. That's kind of what ends up happening there. The session layer, I see. This is why some people like drop them and crunch them all into one, because at these layers up here, it starts to get really gray. The boundaries between them. Start and stop session, maintain order. So whatever. I have never been able to thoroughly explain to somebody the difference between a session, presentation, and application. To me, they're the same. They're almost all the same. And really, the only one you really need to understand, and I'm sure some pedantic person in my stream is going to yell at me in the comments, but is the only thing that matters at this point, if you ask me, is the application layer. Okay, and you'll deal in application layer protocols all the time, and that's what we started out doing with when we were talking about client and server. Okay, so the application layer is the most famous application layer protocol is HTTP. It's actually not just HTTP these days. There's like Quick, and for a while that was Speedy, and a bunch of other protocols. But these at the application layer, what you need to know is, or SMTP is another one. ICMP is ICMP part of application layer? It is, right? I don't think it's presentation layer. I think ICMP might be a good example of one of the session layer ones or something. So what's another one? TCL. No, TLS is kind of one, but not really, right? Because TLS is just a tunnel that wraps up the HTTP protocol. So yeah, well, let's talk about HTTP for a moment. So HTTP stands for the Hypertext Transfer Protocol. Hypertext is text where you click on it and it takes you someplace else, like hyperspeed jumps you to that thing. You're streaming RTMP. Is RTMP application layer conquesting? What is RTMP? Oh, I don't know. Let's go look. I'm trying to find a good example of a layer that's not upper layer. Is this a session layer? A session layer controls the start and end of session. RTMP is which network layer? No, I don't want security. RTMP is the plain protocol works on top of TCP and uses the port number 1935. Did not know that. RTPS, which is RTP over transport layer, TTLS. Presentation is HTTP. You think presentation is HTTP? I don't know, man. I've always thought that was an application layer. Application is also, yeah, that's my problem. That's the problem I have with HTTP. It's like some of the higher level protocols, they kind of squish those top layers. Yeah, anyway. So RTMP, that's another good one. Let's put that one there. These are all just ways of communicating. They're protocols. That's what protocols, okay? And that's, but they're, okay, so when we talk about communicating, there are different types of network topologies. I guess I should probably put that in here. Know what a network topology is, right? I'm so just winging this, but I don't care. Again, this is just to get you what you need to learn. Network topology is how you lay the network out. So you probably heard of peer-to-peer. So, you like, whether you're talking about cyber or torrents or any of those things, there's no central server and a bunch of, clients that connect into the server. There's a bunch of peers and they communicate with each other in a way, and they negotiate things, and they all take a different piece of depends on what they're doing, right, with it. But that's sort of, the network topology is also how the machines are laid out. So it's kind of, let's look for a better one. Network topology. So network topology is the arrangement of elements of a communication network. Okay, so network topology can be used to define and describe the arrangement of various types of telecommunications networks, including command and control radio networks, industrial, blah, 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 blah. Network topology is the topological structure of a network and may be depicted physically or logically. So network topology, Cisco is the #1 router seller still in the world, is used to describe the physical and local structure of a network. It maps the way different nodes are on the network, where they are, whether you have a firewall, that kind of thing. So you're usually seeing maps here and like cool, you know, like charts and graphs and stuff. So, but the kind of network topology we're talking about now is that you have a server that lives someplace, and that can get really complicated really fast. So we're not going to go there now. And then you have a bunch of people that want to connect to it. And so let's go back to our website and play around with this some more. Okay, so we were messing with, where are you? All right, so we were messing around with this thing here. And we're making a request of the server and we're getting stuff back. And the reason I went down that sort of rabbit hole is because I knew I was going to have to start talking to you about HTTP. If you're going to be a pen tester, particularly, you've got to have HTTP memorized. So HTTP has defined that there are different kinds of requests you make of the server, right? So you send the server a GET request. I would like to get this thing. You send the server a POST request. I would like to post this bit of file or data. I'd like to give it to you. There's some other less used ones called PUT. There's, I think there's delete. I can't remember them all, but you can easily look them up. Let's do that. So what are the requests from HTTP? And HTTP requests are really critical because they're in everything today. Which are they're like, you name it, right? You name it, HTTP requests have to be there. I have two diatribe supporting ring topologies. Oh my God. Don't let me, what? Diatribe supporting ring topologies for redundant networks. Oh, okay. Well, maybe Zebrow, maybe you, I am not a network guy. We have Zebrow's quietly in the back row, like saying ring networks aren't that bad. No. Okay, fine. You probably know more about it than I do. I'm just glad it didn't win. So, HTTP requests. So again, the protocol is, hey, I want get this thing, right? So an HTTP request is, the bottom line, it sends a file, and the file has at the very first line the type of request, and then after that it has a number of headers, key value pairs, you know, about what it wants and whether it can keep it alive, the connection alive, how long it is, content length, all this kind of stuff. Your agent, like I am a Mozilla browser, that's how they keep track of what's connecting. And then down below there's a blank line, and then it has the whole body of the thing, and that's a very simple web request. But that's the definition of a web request. And to play around with that kind of stuff, the tool of choice is usually curl, and so we're going to go ahead, like you can use sort of curl. If you don't have curl on your boost machine, you can go ahead and put that on there, right? So get on your boost machine and do apt-get curl and put that on there. But you can do curl, and you see curl used all over the place to act as a client and to request of a server, right? So we're going to request that same page. Let's say it's https://github.com/rbxrob, and this will give me the request. Okay, so this didn't give me the headers or anything, it just gave me everything from there. Let me make a little note here. Let's see here. So yeah, use curl to deal directly with web requests. Well, actually, not just HTTP, but you can do lots of stuff with curl with client requests. And there's lots of other tools to show this. I've showed you the one that's built into. If you get into security and pen testing, you're going to have to learn this horrible thing called burp, which runs inside of Chrome, essentially, and it interjects the stuff in between the requests. So here's the status. So that tells you the stuff that's coming. If you wanted to, you can do this. You You can say, what is it, -I just to get the headers? I don't remember. Anybody remember? I don't have it at the tip of my tongue. I never do. Oh, there they are. Yep. All right. So I just have to do quiet. I'm making it quiet. I don't. Okay. So here's exactly what an answer looks like. I hate burp. I hate it. I want to rewrite it. I would rewrite it in another language or something, but you couldn't do it that easily because it has to kind of be in the web browser because it's kind of proxying between. So proxy is something that like passes something along for you, and burp is a security thing that sits inside your web browser and messes with the requests and fuzzes them and makes them different and tries different things and until it finds something that allows you to break in. And it's a pretty mandatory tool. It's also like $3,300 a seat per month if you're going to get it professionally. And it's written all in Java. So, it doesn't run in your web browser actually. You request, it's like a server and you request it. But if you're going to get into security, you're going to have to, it was kind of, I didn't mean to mention it. About your more prominent use of GitHub these days. Yeah, well, that's an old one. That's an old decision. So HTTP2, this is the answer. So remember that client server thing? I made a request of this website and here's the answer I got back. I told you I get back the answer. 200 means, hey, I'm here. You get, a bunch of information here. These are experimental headers. All of them mean different things. I just don't want to get into that right now. This is important though. So this is the type. This is what the answer your web browser decides how to show it to you. So if you get like text plain, you get to see it's just text. If you got like, what is some other ones? Like JPEG or something, it will draw the image in place. Sometimes you get it when it doesn't know, it'll download it. So this is an example of a client server request. Hey, there's my cookie. Somebody could probably use that cookie. Yeah, I hope not. I'm probably gonna have to go change it. I don't think that's a secure session cookie though. No, it's not. We'd have to use it like right away, which I probably shouldn't say out loud. But so because that's how they take care of things, they negotiate for stuff and then they send cookies back and forth. And yeah, so that's how it happens. So let's go look at eat all the cookies. Yeah, just don't do that. That'd be not cool. But I have over here, here's where you see all the requests and stuff. I don't spend a lot of time doing this, but you need to know how to do it. You need to know it's there. You need to know how to talk to the protocols. You need to know what a server is and what its job is. You need to know whether some servers keep the connection open, whether they close them down. Okay, here's a quick question. So Twitch, right? We're using Twitch all the time. Does it keep the connection open or close it? Keeps it open, right? IRC, by the way, that's another protocol that we use. Actually, Twitch uses it as well. So those are all client server protocols. The web people, any other Twitch streamer will show you a lot of this stuff better than me. They spend a lot of time using this. I'm trying to find the one that shows it. So here's the status messages, but I think you can click on some of them and see that. No, that just shows you what the thing was. There it is, response. Okay, so there's the headers. I actually don't like using the web tools for this because it removes me from the protocol, right? And so, I want to, before we leave tonight, I want to show you a fun tool called Netcat where you can actually make your own server client protocols, show the JavaScript. Yeah. So here's the status code. Here's the remote address that answered. This is a request that we made. At 443, remember we talked about ports, right? So there's the port. There's the IP number. Refer policy. This is a thing where some people put in their website JavaScript that tries to get web access to other stuff, and it's a big security issue. And I'm really oversimplifying it, but you can go look at it. And there's the content type. There we go. Image, SVG plus XML. So you can look at all this stuff and you can watch it. Just take this away. Go screw around with the network tab in Chrome or Firefox. Just look at it all, play with it, redirect some things. And you'll kind of get a sense of what's happening when you request something. All that stuff comes down. And the real goal here is for you to understand, and be able to intuit that what's going on, right? And you're just requesting a bunch of stuff, and it's coming down. Is it keeping the connection open? How long is it taking? Also as a node fetch, yeah. So there's talking about node fetch. There is JavaScript itself now has stuff that can run in the web browser. Well, actually, it's had it forever. That can make a request without, that indirectly uses the web browser to make the request for it, but it doesn't ever show up on your website or anything. And so that's a really common thing. If you've ever done like Twitter and you've done lazy loading and you have messages at the bottom, they all of a sudden appear. That's because the JavaScript that's running inside of the website for Twitter or whatever is busy drawing the page as it goes, and it's making these HTTP requests in the background of the server in when they're needed. That's called lazy loading. So again, talk to any number of web people who deal every day in web tech on Twitch and YouTube will be able to explain this far better than me, but you just need to know that it's a thing. Okay. Not only is it a thing, it's an important thing because the whole entire world is going Kubernetes crazy and, container crazy, and Kubernetes is just HTTP. So Kubernetes is just a big server. That's all it is. And it's an application programming interface, which means rather than getting a picture or an HTML page or, like we saw there, like an icon, that you're requesting structured data. And that structured data is then used by the application, which might be, kubectl or any number of other, it stands for the command line interface, by the way. It's not control. I found that out today. By the way, I'm going for my CCAT in case anybody wants to come along with me for the ride. I'm going to be studying like live and making playlists of it on the weekend. Postman's a good one. Yeah, Postman's another good one. That's a graphic-y one, right? I don't use Postman very well. Postman, yeah, but so this idea of having a client server request is fundamental to all tech today. All tech, any network-based technology has this idea of web server, of server and client, requesting a thing, getting it back, and whether or not you're doing it from HTTP, which is kind of slow, or you're using a protocol called gRPC, which is sending protobuf messages back and forth, which are wicked fast and binary and super tiny, you're spraying. You're actually not really making requests, I guess, and when you're playing a game, like a UDP game, like a first-person shooter, you're not really making a client server request. You're connecting to the server, and then the server is spamming you as fast as possible the state of the entire game all the time. So there's not as much request response going on. There's no time to do that. So this is all stuff you need to understand at the fundamental level, so you understand what the client server is going on about. It is really fun to play with. I'm trying to find the API server, Kubernetes API. I think this is just like a open API specification. So here we go. These are all HTTP headers. HTTP is by far the most important application layer protocol right now because everything uses it to communicate. But there's no reason you have to use HTTP. So we jump ahead and do that. Let's play around with some more stuff. So this is the boring stuff. Let's get to the fun stuff, right? As the fun stuff, the boring, if you do any of the like security games, like Try Hack Me or Hack the Box is my favorite, or Over the Wire, which is free, or Pico CTF, that's another free one from Carnegie Mellon University. All of those are really fun ways to learn about networking and how to break. They're in a hacker context, but you'll learn a lot about how networks work and how to break into them and how to use the applications and own them if you want. But what I was going to try to do, and I don't know if we can get this to work today, but in the old days we used to play around with Netcat. Okay, so first of all you have to get Netcat, and I could not for the life of me figure out where the Netcat. So let's do this stuff from our Docker container. Okay, so let's do Docker. If you still have your boost containers, guys, if you don't, that's fine. Docker start dash AI boost. I have my old one still around here. Which NC? Do I have NC on here? No. So Netcat. I think I just read just tonight that Netcat has been combined with Nmap. So, and I want to get Nmap on here. So app, and Netcat is a tool that you can use to be a server or a client. It also allows you to script interactions with it directly, like byte for byte, not like curl. Curl is cool, but it takes care of a lot of the, the connection and stuff like that. And Netcat, actually, you're going to do a lot with Netcat in the hacker space if you get into that. So I thought it'd be fun to play around with it. So apt-get, it's been a long time since I've done anything with it, so we're going to see. I'm trying to find the best one. Does anybody know which the best Netcat is out there? It says, okay, so yeah, there we go. So look at that. See, Nmap comes with, Nmap is now coming with, ZenMap. That's the new one. Yeah, ZenMap is coming new. We need to get Netcat NDiff. I've heard ZenMap is the one that is faster than Netcat. These are, I wanted to talk about these tools. We're going to play around with each of these tools a little bit this week. And you know what? We don't have time. We only have like 7 or 8 minutes. So we're gonna have to learn another couple tools along the way too. Right? Is it control? All right. I don't think it's control. That's what they told me in the training anyway. Who knows which to believe though? So we got Netcat on there. Nmap, but we're gonna do Netcat. We're gonna be playing with these tools this week. So we got Netcat on there, which is also NC. Must specify host or quit. Right. So, okay, this is fun. We're about ready to play. However, there is kind of a problem here because we're not in the same host. So let's actually, let me try something else because we were very careful not to poke holes. Yeah. So let's actually do something different here. It's gonna take me probably 6 minutes to do it, but so here's the goal. So we're gonna put Netcat on here, and we're gonna connect to a server from one terminal. You guys don't know about TMUX yet. We haven't done TMUX yet. I have to figure out how to get TMUX in your skill set earlier, but so you have one terminal and then another terminal. I'll have 2 windows, but you can have one terminal here and another terminal, okay? And you can connect from the one thing to the other one, right? And the problem is that you won't be able to do that unless you start up a new container. So let's do that. It's going to take a little bit longer, but it's not going to hurt. It's good practice. So I'm just going to start an Ubuntu container. And so let's do that. Let's say, I don't know, Docker run, and I'm gonna leave it around. Yeah. Now let's throw it away because I don't want it to take all my RAM up. So Docker run -it-rm to remove it later after it's done. And just remember not to exit it because you'll lose all your installation and stuff. I mean, if you don't want to do that, you can just detach, and we talked about doing that. Have reports after this. No, I don't think you can. I don't know how to do that. If you can do that, I'm too new to containers. Okay, the reason we're having a problem here is, check it out. So if I do Docker ls, I am still a Docker noob. I'm just going to own it. And I do Docker ls. It'll show us, Docker ps. Ugh. And where's my boost? JHub content. Where's my, he's not running right now. Let me go ahead and start. So, yeah, Docker start -AI boost. That's the one we've been using. And open a new window here. And if you Docker ps, you should see it. So here's boost, but you see how it doesn't have anything mounted? It doesn't have any ports exposed. That's what it's called. I don't think you can add -p in the run, if I remember right. I could be wrong. Let's try it. Because I think that has to be done when you do the run the first time. But I I think that that's like locked into the image when it's first run. I don't know though. Let's try. So let's do H host. That will set the host network. See, I don't think it'll work. Right. This is what I was afraid of. So I don't. You can't provide those things. And run creates a new container, so that'll throw away our boost container. And we did that on purpose. We deliberately made it so that our boost container, we knew we were going to eventually throw it away, right? And the boost containers are supposed to be ephemeral, they're supposed to go away anyway. But we decided to keep it around for safety. We didn't want to have it talking to our local network. Well, this is now one case where it might be fun to have it talk to your local network. And if you have, if you had like screen or something installed, you could actually connect and then have two different screens and go back and forth between two. That might be the thing to do. That might be the thing to teach you how to do. How do you, is for the image, -p is for the container, right? You can't do any of that with the start command. That stuff is only for the run command, and when you do a run command, it makes a new container. Yeah, I'm familiar with. You can't. I don't think you can alter the state of a current container though. Once it's become a container, it's not an image anymore. So once you do run, you're stuck with whatever it mounted up front. I hope I'm wrong on that, but I don't know. Let's go see. So it says, how do you map a port on running container? Running container wants to export a port. Any way quickly to do this? Any progress? You can't change the port mapping on a container, but you can stop the container and restart it. -p host container flag, or by using the control director of the Docker compose. Okay, let's try that then. All right, let's try it. That's new for me. So this will be fun. So I hope I don't lose it. Docker stop boost. Yeah, exposed to image creation. Well, this little write up that they sent us in Twitch. Here, let me send you the link to YouTube. This looks like we might be able to do this. And I don't claim to be a Docker expert. I made my first Docker file a month and a half ago, so I'm still learning on that. And I have never been so convinced that everybody needs to learn containers. As soon as you know the terminal, you need to learn the containers. All right. So let's do this. Let's try. Let's do start. I could have swore I did a start. Was it because I wasn't stopped before? -p host container. You can't change your port mapping on a running container. Can I change the network? I guess you can't change the network. Oh well. I bet you can expose a port apparently, right? So let's expose. I don't know. Let's do something crazy like 666. How about that? I watched 4 hours of my yesterday. Today it was all Excel. Well, we'll do 4 6s, and the port number has to be above 1080 in order to not get in trouble with root and have to use root for everything. So let's go ahead and put it really high. 66667 is actually the official port of IRC. So maybe we don't want to do that. IRC is the devil's protocol. So anyway, this is fun. Docker, no, but if you do Docker run boost, according to her, that'll blow away your previous one. Boost is the image. Pretty sure you can't do this. Yeah, because I do not think you can do a Docker run boost, because boost is the name of a container. Yeah, see, yeah, I think I'm actually right on this one. Go figure. You cannot add ports to, now it says you can start it with it, so I want to try that. We're gonna try that. By the way, you have to put, you can't go over 32,000, dude. 4268. I don't think you can go over that. You can't just run on a container. That's what I was just gonna say. Yeah, conquesting. Looks like this salute. So devil saluting. How about this? 6868. I don't know. You have to do 2 of them though. So this P exposes a port, and now you know what a port is. I couldn't talk about ports before with Docker because you didn't know about networking. So now you're supposed to know that a port is like a doorway into a specific type of application or thing. We're just picking a random one because we're making our own sort of application here. No, man, 65535. That's Minecraft. Oh, it's six. Oh, the maximum number. Right. Sorry. Thank you for that. I thought it was 32,000. It's not. It's 65. You're right. Absolutely. Thank you for that. Thank you for that correction. Yeah, you cannot do this. So this is actually interesting because this means that this whole thread is wrong on GitHub, because this thread on GitHub is saying, hey, yeah, you can do it. No, you can't do it unless it's on a run. So how do you map a port on a running container? You don't. You like restart the container. You can't change the port on a running container, but you can stop the container or restart using the p container flag or by using the correct directive in the compose file. No, this is. See how many times I got voted down? It's not true. You can't do that. I'm glad that got voted down. You're right. You have to use Docker run again, and when you use Docker run again, that forces you to make a new container and throws away your old one. Don't do that because it'll throw away your whole boost container. So, but there is a happy medium. Hey, I'm happy I got it right. Okay, so the what we can do is make a new container just for this, right? I don't know if we have time, but let's just do it. So Docker run. We haven't done a Docker run in a long time, so this is a good idea. Let's do -IT for interactive TTY, and then --rm, and then we're gonna do we're gonna do it just in a Ubuntu container. We could do Debian, but Ubuntu's fine. It has a bigger repo and all that. So just for today, and then we'll give it a name. So let's call it just Netcat or something. Right now, here's where it gets interesting. Right, we need to give it. We need to poke a hole in the port, or we can do something even more insidious. We can tell it to join the current host network, and if you do this, it says, "My network is your network. We are going to share." And I think I got that right. I might not be H though. I think it might be something else. Did I get that right? Anybody want to confirm that for me? Man, dog. I didn't look. When you watch me, you're going to see me making mistakes, looking stuff up. You know why? Because that's what you're going to do, and that's what every professional does. And don't let them tell you differently. If they make a nice polished YouTube video where they don't have to look anything up, don't trust them. So, what? Okay, it does say you can edit the host config.json. Maybe hell no. Yeah, the image goes at the end. I know. Back to the bleachers again. No, thank you, Zebrow. You're doing great. I can't remember. Seriously, I do not do this command very often, so this is fun. Host. Okay, there it is. Host. Yeah. No, the host is not the one. Host is different. We want network. Where is it? There's so many people laughing at me now. There's a way, instead of poking a hole though. It's not, you can do it -p, but I don't want to do -p. -p only exposes one port. I want to say, I want this container to have full access to my same network. And I know it can be done. I think it's network, but I don't remember the exact command. I think it's, I want to say it's, where is it? My gosh, look at all that stuff you have to go through. It's volume driver. -p over -p. No, you can do that too, but there's another one. There's another one I like. I'm glad we're doing this because my memory's getting fading on this because I don't do it every day. No, we're gonna do. It's not name. It's not. Oh, there it is. It's network. It's network, and you can actually make a different Docker network and have it all share. I did that for Kind recently. Yeah, we're not publishing all. No. Not that one. So, yeah, the image has to come last. And so this is going to be the name. And H was just going to be, the H is just the host name. We don't care about that. And so then, edumacation. Yeah, I'm very loosey-goosey. So let's do this. It's network. It is network. And we're going to say host Ubuntu. I'm pretty sure that's it. There. It worked. Oh my gosh. And it even, that's so weird because it says it's root at live. That means it's on the current network, but it's in a container. Now here's how I know, because it's not going to have anything. Watch. There's no VI command. This is like a brand new container, right? I'm gonna put this line in the show notes. I like kind of like saying show notes. Makes me sound fancy. Find that later in the show notes. God damn it. You know what I did? I did it wrong. It's probably time for me to go now, but this is so much fun. I'm actually gonna stay here a little bit longer. My streams have been longer than 40 minutes lately, just because. You know what? That Pomodoro is screwing me up. Yeah, it's a weird bug with Tmux, where if you have something that's like clearing, it'll clear your other windows too, and so you can't cut and paste. It's really weird. So this one lives in your host namespace, but it doesn't have any packages. Exactly. So, and that's a little scary. It doesn't have disk access. So don't let that mislead you, right? What I just said. So there's two ways to give your, nice safe container access to stuff if it's host. One of them is this -p. It's called exposing a port. So if you just want to let one of those ports in, like 80 or 8080 or 5000 or whatever, you can do that. But if you know that you're going to be working with the local network of your host computer and you're safe to do so, you can do this. You can do -- network host, and then it has access to you. You are sharing the same network. It's as if you have a mini little computer, not really, right? Running. It's kind of like a VM, except for it hasn't been NATed or anything. It's directly talking to your network, for better or worse, right? And so since we're playing around with networking stuff, I thought it'd be good to do this. Now the problem here is that none of the tools are here, right? So if you want to learn about all these things, you need to do them now. And we put host network namespace. Did I do it wrong? Network host namespace. Did I do it wrong, Zebro? Host network. No, I am okay, because you have to use the keyword host for the network, right? And actually, you can look at your networks. I didn't know this. I did not know this. Yeah, you want to do a network ls? It'll show you all your networks. There you go. I told you I need to go through like a full Docker. I know how to make Docker files. I'm pretty good and pretty dangerous, but there's some stuff in here that, so these are all the logical networks that are there, right? Bridge equals internet access. Did not know that. So if you want to give internet access to your, so host is just host, and that's super cool. So learn something about Docker. Once again, can I just say how grateful I am that we chose to use Docker for this boost? Because up until now we hadn't been using it for anything, but it's so fun to be able to go through all the steps, to repeat the steps again, and we're about to do that, right? And I'm going to quit here in 10 minutes or so and just do this thing here, but because what do we have to do here? So do you guys remember? We've done it many times before. Do you remember? You have to do sudo apt. You don't have to do sudo. You can just do apt update to get the latest packages, and then we're going to do apt. Someday you should do apt upgrade to get the latest version of the OS. We're not going to. We're just going to do apt updates. So you can do apt install netcat and nmap, and you could put them all in one line if you want. And then we can do apt install netcat. See, I want to install them so they're in my container, but I can still use them from my host system without screwing up my host system. Does that make sense? Upgrade doesn't do the OS. No, it upgrades. Upgrade. I was told rather loudly that I should always do apt upgrade as well as update. So, yeah. Upgrade just takes any of the existing packages and ups them a notch. And since the image for Ubuntu might be behind, that would upgrade all the packages. I'm going to try it. I don't know. Let's see what it does. See, there's some packages that need to be upgraded. Dist upgrade does. Oh, right. Dist upgrade. Yeah. I mixed the two up. Thank you for that. Yeah. Dist upgrade does everything, and upgrade just does all the packages that have been installed and gets them to the latest level. So now we should have Netcat on here. Let's get nmap as well. But let's just see if we have Netcat here. So we have Netcat. Yay, we have it, right? So Netcat's a pretty simple command. I'm gonna have to take time to get used to it. Netcat can be used to connect to something, and when I say connect, I mean bare bones connect. Like it just directly connects was like, I found it, this network host was like, wait, are you telling me that I'm connected to the other network and so it sent my upgrade to my local system? Please tell me that's not true. This is why I'm so afraid about having beginners connect to -- network host, because I don't want it to, bridge me, share my IP on the network if you have Ethernet. Yeah. All right. So there we go. Okay. What's going on here, people? If it's a bridge, your computer is a router. Yes. Oh God. Yeah. I don't know if I want to do it right now. So here's what we're doing here. This is all I really meant to do. I wanted all this Docker container stuff that we've been doing is very educational. And why? The reason we're doing it is because I don't want to mess with my host system, right? I want to, now, I mean, the proper way to do this is probably to do the -p. I mean, let's be real. Should we go back and do it the safe way? Yeah, I'm going to. I'm throwing this container away. Sue me. I'm going back to my command and get my SQs back. I'm going to do the safe thing because I'm just scared. Exposing my entire and putting my container, this container that I'm messing around with, on my host network is scary to me. So because I don't know, it might talk to the wrong thing. You know what I mean? Yeah, network host. Yeah, that's a good one. So, but I'm going to do. Let's just do one port at a time. Much safer. Much safer. So let's just do -p. I don't know, 6868. Right? :6868. That says expose port 6868 of the container to the host. The end. Nothing else is exported or exposed. That means that my container has no access other than that port to my host system. Now, the -- network got me a little bit worried there, so I'm going to take it off. Expose your whole network, maybe. Yeah, well, yeah. So there we go. So now we have, and I like that this did this. It put this here. When I know that's what kind of alarmed me is when it said live. That meant that it did a DNS resolution or something by joining the local network and being given its own name, and that's what a domain name is, right? It's a name for when people pay attention, security testing or natural selection. Yeah, that's a funny one. All right, so let's do Netcat again. So I threw everything away, so I have to do it again, but I don't care. So we can do apps. So we're doing it interactively, so we can just use apt. Normally you would use apt-get if you weren't. So you do apt update -y and apt upgrade. I don't know if there's a -y, but we'll do it anyway. And apt install. What are we doing? You can't read it. It's behind me. And map. No. Netcat. Netcat. Is it Netcat or Netcat? I think it's Netcat. I got it wrong. So many mistakes. It's the same as port forwarding. Yes, it is. Yeah. Yep. That's exactly. Port forwarding is a good thing to learn about too, by the way, because that's how you like host Minecraft servers at home and stuff, if you want. Netcat. I can't see that. I typed Netcat instead of Netcat. So, yes. All right. So let's actually fire up a server on that port, shall we? So you can do NC as a shortcut, I think. Yes. You can do Netcat if you want, or you can do NC. And we're going to use Netcat as a server. So to do that, I think it's dash. You have to give it a server flag. Is it -S or T? I can't remember. Man Netcat. Netscat. I don't know what that is. Oh, that's right. We don't have man pages. Damn it. All right. Well, let's go look. Search on the internet. Netcat as a server. And let's see. I don't remember the switch. So if you just do Netcat and you give it an argument, it'll connect to that system on whatever port you say. But if you want to make it into a server to be connected to, you have to give it a switch. And I don't remember it, so I'm looking at it. Some people might have it memorized. A lot of hackers use this to break in. They'll put Netcat in the rootkit, and they'll get on there and they'll pop it up, and then they'll use that as a terminal. Yeah, there's some pretty nefarious. Oh, stash L. That's it. Yep, there it is. There's some pretty nefarious things you can do there. You can actually. There's one guy who put it in was it /temp or it was and made it look like an SSH daemon and everything. And yeah, you can. People use Netcat a lot to create backdoors into systems. So it's kind of fun to learn. So nc-l-p, and then we're gonna do, what did we say? 6868. We have to get that right, or it won't work. All right, so this is the system. So I'm gonna split the window. So on the top of the window, you've got the server, like remote access. Yeah, maybe not great. And on the bottom one, I can actually use Netcat as well. This is in my host system, and for you to do this, you would need to start another terminal with your base terminal, whatever that is. So if it's Windows, it would be WSL. If it's which is a little bit hard because you'd have to install Netcat on there too. I'm wondering how this would work for an absolute beginner. But you need to have two different systems, right? So over here we have Netcat, and we're just gonna connect to localhost, which is, you guys got the joke, right? So have you ever seen this before? There's no place. Yeah, I'm gonna do it here. There's no place like, I had a mat. There's no place like 127. This is a really old joke, actually. Nobody calls it that anymore. In the old days, 127.0.0.1 was also called home, and it's more common to call it localhost now. Localhost always refers to the computer you're on or to the device you're on. It never ever refers to anything outside. So people ask all the time in the chat, how do I test my website? Well, you run a server on localhost using browser sync or something, and then you can run everything on your computer. You don't even have to have internet access. You can do all your web development, your Kubernetes development, cloud native stuff, all locally. And that's what Kind does, by the way, if you want to get it. I've been really enjoying it. So NC, so it says I have to connect to something. So localhost, right? But if I just do this, it'll fail because there's no port. So I have to give it the port. Remember we talked about this localhost is getting me to the building or to the house or something. And port is which door to connect to. Well, I opened up a backdoor, on 6868. Not quite as dangerous as the other one. So now I'm connected here, right? So I can say, hello there. You see that? This is so cool. I just make my own protocol up. Who needs HTTP? I can make my own protocol. Should we use JSON? You know what's even better? What's even better is you can actually take this Netcat line right here, and you can pipe that into a bash script and just have the bash script process. Yeah, there we go. Shall we play a game? And you go over here. Let's go up to the other one. Oh, damn. What'd I do? Oh, damn. I'm not doing very well today, guys. I'm not. I'm sorry. All right, so let's go. I'm trying to go up here. Yeah. No. You see that? But I want to. I don't care. Now, now imagine yourself like in a 1980s hacker movie, and one of you needs to set up a communications channel really quickly, and you've got Netcat on the system, and so you run Netcat, and then you just tell them the port. You say, I'm on port so and so, and yeah, it totally would. Yeah, and so you can. All it is a pipe. You remember the Unix philosophy for the win? How many times have I been telling you Unix philosophy for the win, right? And I'm not going to do it right now because I'm 21 minutes over, but I challenge you to go use your bash skills and NC only and tie NC and pipe it into something, right? Something that's constantly reading from standard in, like any script you want with the while read in it. And you can listen and you can listen to each of the lines that are coming in, and you can make your own interactive chat that has specific responses. You can write your own shell. You can write your own interactive shell, and you can have commands, and you can make it so that after every line it puts this, right? And then down here they have to write something else, you know? I mean, you can totally do it because it's a 100% connection. Netcat actually is driven by character return line return, and in that way is absolutely the best possible way to shell script really quickly a pseudo protocol. Now, if you have that, and if you have Netcat, and by the way, a lot of times you'll get something equivalent to Netcat. So there are a lot of backdoor tools to get on a system that all they give you is this, and then they just give you that connection, and then you have to, tack on your own little filter scripts. And you love filter scripts because you're using them for VI, right? I'm telling you, the Unix philosophy. You never thought that you're learning Vim the right way was going to help you write backdoor shell scripts, did you? But it did, because the cognitive overhead to learn how to loop through and examine each line of input and do something to it or respond to that is exactly how you write a Vim, script, a little Vim shell script to transform a little bit of code. So go have fun with that. That's it for me today. If you want to have fun with the server and client, just remember the main things to take away. Know about the network layers. This is exactly how reverse shell works. Exactly. So this now you hopefully you have a fun way to play around with client server and take turns being the client server, right? And you'll understand more what's going on in a web thing when you look at it, whether you're going to do pen testing or you're just trying to figure out how your protocol works and you want to get ready for some sort of cloud native education. All of those things depend on client server, and they are really fun to play with, and in this way. I mean, you can make your own chat app. Somebody out there should do that. Make your own shell scripting chat app. You love reverse shells. I love port forward to DigitalOcean drop. So when I just play a game, I give them my URL on the port. There's so many things you can do with this. And once again, the Unix philosophy, because that's why I wanted to show you Netcat, because Netcat is just transferring your data to something else. You don't care. You don't care what that thing is. You could make a complicated Go code or Rust or whatever that does some crazy binary interaction that nobody can read, or you can just do a bunch of text. Doesn't matter. It's just all getting catted out to everything. That's all. We'll see you guys tomorrow. Bye.